We hear this all the time, right? AI models learn. It sounds complicated, maybe even a little magical. But what if I told you the core idea behind almost all of modern AI is as simple as finding your way downhill in the dark? Let's get into it. Okay, I want you to actually picture this. You're standing on the side of a massive, foggy valley, and you're wearing a blindfold. Your only job is to get to the very lowest point. How would you do it? Seriously, think about it. This might sound like a weird riddle, but the answer is pretty much the key to understanding how machines learn. So, this blindfolded hiker, that's our AI model. And this giant, foggy valley, that's the entire landscape of all the possible mistakes the model could ever make. The model's goal is exactly the same as our hikers. Get to the bottom, where the error is as close to zero as possible. In machine learning lingo, this terrain has a name. It's called the loss function. You can just think of it as a map of mistakes. Every single spot on this map is a slightly different version of our model, and the altitude of that spot tells us just how wrong that version is. High up on a peak, that's a huge error. Down in a valley, now the model is starting to get things right. So, how does the model actually move around on this map? Well, it adjusts its parameters. These are basically thousands, sometimes billions, of tiny internal knobs called weights and biases. Just think of them as the hiker's GPS coordinates. Every time the model tweaks one of these knobs, our hiker takes a step to a new spot in the valley. What you're looking at here is a 2D version of that loss landscape. The blue areas are those nice, low-error valleys we're trying to find. The red areas are the high-error peaks we want to avoid. The goal is simple, right? Get to the blue. But here's the challenge. Our AI hiker starts somewhere totally random on this map, and it's completely blind. It can't see this picture. Which, of course, brings us to the million-dollar question. If you can't see the map, how in the world do you know which direction is downhill? You can't just look for the blue parts. You need a different sense. And that sense is called the gradient. Now, this is a concept from calculus, but you can forget all that. Just think of it like this. It's the feeling of the slope right under your feet. You don't need to see to know if you're on a steep hill, right? The gradient tells you two things: how steep the ground is, and, this is the important part, which direction is pointing straight uphill. So if the gradient always points uphill, the solution is beautifully simple. Just go the other way. This process is called gradient descent, and it's basically a three-step loop. Step 1, you feel the slope right where you are. That's calculating the gradient. Step 2, you take a small step in the exact opposite direction. And step 3, you just do it again. Feel the slope, take a step. Feel the slope, take a step. Over and over, our little hiker inches its way down the mountain. All right, so walking downhill seems pretty straightforward. But as it turns out, there's more than one way to get to the bottom of the valley. An AI can choose different strategies for its journey, and that choice makes a huge difference. We're going to look at two of the biggest ones. On one side, you have batch gradient descent, or just GD. On the other, stochastic gradient descent, or SGD. You can really think of them as two completely different hiking philosophies. Let's start with batch gradient descent. This is our super careful, meticulous hiker. Before taking a single step, this hiker looks at every single piece of data it has to calculate the absolute perfect, most accurate direction downhill. The result, as you can see, is a very smooth, very direct, and confident path straight to the bottom. And then you have stochastic gradient descent. This is the impatient hiker. Instead of analyzing the whole landscape, this hiker just glances at a tiny patch of ground under its feet, based on just one or maybe a few data points, and immediately takes a step. The path is noisy, it's chaotic, it's zigzagging all over the place, but because each step is so incredibly fast to calculate, it often gets to the bottom much, much quicker. So here's the trade-off, and it's absolutely crucial. Batch GD is slow. It's computationally very expensive because it's using the entire data set for every single step. But it gives you that smooth, stable path. SGD, on the other hand, is lightning fast and cheap for each step, but its path is noisy and indirect. So which one do we actually use? Well, for the massive data sets that power modern AI, almost everyone uses some version of SGD. That speed advantage is just too good to pass up. And that really is the heart of it all. This simple process of walking downhill isn't just a clever analogy. It is the engine. This fundamental idea, taking a tiny step against the gradient over and over and over again, is what powers everything from the app on your phone that recognizes faces to the largest AI models on the planet. So it all comes down to a blindfolded hiker patiently finding the bottom of a valley. And it really makes you wonder, doesn't it? If this one simple, intuitive process has gotten us this far, what other, even deeper valleys of knowledge and understanding are out there, just waiting to be explored?